All right, so we are in section 2 of our shadows unit, and we're going to focus on the interior of the angles of the polygons. Okay, so as you can see in your notes, it says to find the sum of the interior angles of a polygon, you can use one of two equations. The equations are based off the fact that you can divide the other shapes into triangles, and that the number of triangle, or the sum, as we saw in degree discovery, the sum of every triangle is 180 degrees. So in the degree discovery activity, when it was asking you to relate it geometrically, we're going to establish that here together. Okay? So first of all, as we're going through here, it says use the designated vertex below to split the polygons into non-overlapping triangles. Then we're going to fill in the table. Well, first of all, if I designate this vertex here, and I try to divide this into more triangles, I can only draw to the other vertices, or vertices, and when I do that, I just create a side. So I really can't divide this up, and so it's just going to stay the way it is. Moving on to a quadrilateral, going from the designated vertex, I could draw in I could split it up going to one other vertex. If I draw to the other sides, it's just a side, okay? So that means that I can divide this quadrilateral into two triangles. When I go on to a pentagon, I can then, from this designated vertex, draw in two diagonals, splitting it into three total triangles. And then from the hexagon, from this designated vertex, I can draw in three diagonals, leaving me with four triangles. And let's go then through this table here, using this information that we have. Triangle has three sides. There's one total triangle on the interior, and so 1 times 180 is 180. A quadrilateral has four sides, and I was able to divide it into two triangles. And 2 times 180 is 360. Pentagon has 5 sides, divided into 3 triangles. 3 times 180 is 540 degrees. Hexagon is 6 sides, 4 triangles. There I was able to divide it into. And 4 times 180 is 720 degrees. And so this is looking at developing this equation geometrically, relating directly how many triangles are in that shape. When we were going through degree discovery, we were really just using the table and looking for correlations between x and y, writing that equation, which is fine. So now, let's think about this. I have any number of sides. For my last row here, any number of sides. So I would have an x. How many triangles would be there? What pattern do I see up here? 3 to 1, 4 to 2, 5 to 3, 6 to 4. It's always what? -2. So the number of triangles is always 2 less than the number of sides. And that number then is the number of triangles. The number of triangles times 180 is the number of degrees in the shape. Okay? And so that, again, is how we could get equation number 1. Without using the geometric properties here, just looking straight from the table, you could get the second equation. You're seeing that every time you are changing by 180, and then you are subtracting off 360. Both of these equations are equivalent. If I distribute the 180 times x, I get 180x. 180 times -2 is -360. Okay? So either one of these are acceptable equations. So let's go ahead and practice here. How do we How can we use these equations? Looking at example number 1, it says, what's the total angles in a polygon if it has 15 sides? So immediately think, oh yeah, x minus 2 times 180. Plug in 15. 15 minus 2 is 13. 13 times 180 in your calculator, you should get 2,340. On example number 2, it says the sum of the angles is 6,480. We want to classify the polygon by the number of sides. So what was that? You can. You could divide by the 180. We could work backwards. Okay? So we can, if we have our equation here set up, 6,480 equals your x minus 2 times 180. You can divide both sides by 180. What do we get when we do that? $36. That's a very quick method here. So we get 36 equals x minus 2. That's what's left. All we'd have to do then is add our 2 over. And how many sides would this shape have? 38. So we'd call it a 38gon. So we discussed this a couple times. If the shape has more than 10 sides, it's just an n-gon. It's the number of sides it has, so it's a 38gon because you've got the x equal 38. So on number 3, it says a certain decagon is regular. And again, regular means all the angles are the same size. What's the measure of each angle in a decagon? Start with your equation. X minus 2 times 180. Okay, that would give me the whole entire sum. Once I find that sum, 10 minus 2 times 180 or 8 times 180, you're going to get 1,440. When you know the whole shape is that, we can divide by 10. Or recall on the end of part 2 of degree discovery, we established our equation. You could simply just start with this. X minus 2 times 180 divided by x. So if you type this straight into your calculator, you would take 10 minus 2 times 180, hit enter, and then divide by 10, and you would get your 144. So on number 3, it's similar. I guess this should technically say number 4, shouldn't it? So on this question here, if each angle of a regular polygon measures 120, classify by the number of sides. It's similar. We want to work backwards. However, if we go with our equation here, divide by x, we can't do anything with this problem until we get rid of the divide by x. So to start out this equation, or start out this question, you would take your equation, x minus 2 times 180 divided by x equals 120. Because in this problem it says each angle equals 120. So to get x by itself, we're going to multiply both sides by x to get rid of the x in the denominator. You also want to, which leaves you with x minus 2 times 180 equals 120x. We have to distribute the 180. And then 180 times x is the 180x that we talked about earlier minus 360. That second version of the equation, when you distribute, that's what you get, where it equals 120x. So it is 3 steps to get x by itself, but they're totally manageable steps. So again, you multiply both sides by x, distribute, and from right here, when we now have x's on both sides, we do have to subtract 180x from both sides. We're left with negative 360 equals negative 60x. We can divide both sides by negative 60 and then still get a positive answer. And x equals 6. When the problem says to classify, we want to go ahead and say, okay, what's the official name? If the sides are less than 10, we don't want to call this a sixgon. We want to go ahead and call it a hexagon. Okay? But again, if you get an answer here and it's bigger than 10, let's say the answer was 35, you would say 35 gon. All right, so just a few more problems to work out together here. If you flip over to the back side. So starting out, okay, on all of these problems, your first step, if we're going to solve for x inside of a polygon, you're going to say how many degrees is their total? Okay, well then you count 1, 2, 3, 4, 5, 6. Use that simple equation, x minus 2 times 180, figure out what the total number of degrees is. So this is a hexagon, it equals 720 degrees. From there, we want to set up an equation that makes sense. We want to combine like terms. We want to add up 90, 90, 140, 150, and 130. We want to add all those up, and we know that all of those values then equal 600. So we're left with 600 plus x equals 720. You don't have to write this first line out. You can just add those up in your calculator and write this second line. So then there's only a one-step problem to get x by itself. So subtract by 600 on both sides, and you find that x is left with 120 degrees. So on example B, we have a couple different x's here. How many times does x show up? And when there's not a number in front of it, we know it's 1. 1x, 1x, and 1x. How many do we have? 3. However, I skipped the first step. How many sides does this shape have? 5 sides. 5 minus 2 times 180. It's a pentagon. What is their total? 3 times 180 is 540 degrees. You always have to find what your total is before you start the problem. So back to this now, combining like terms, x, x, and x make 3x. And then in your calculators, let's add up 25, 120, 60, 75, and 50. What do we get in there? Reagan, what did you get? 330. Okay. And now it's a two-step problem to solve. Subtract 330 from both sides. What is that, 110? 210? Nope. Yep. I don't know why I second guessed myself. Divide both sides by 3. So x has the value of 70. All right, let's go ahead. I'm going to give you about 90 seconds, 2 minutes at most. I want you to start C and D. All right, let's go ahead and talk through example C here. To get started, we want to make sure that we figure out this has 4 sides. So 4 minus 2 times 180, we know that we're going to have an equation equal to 360 degrees. Combining like terms, we have 5x and 3x, which make 8x. Now, something to pay attention to, this is a negative 8, positive 51, positive 4, positive 89. When you combine those constants, you should have got 136. Then we would subtract 136 from both sides, leaving us with 8x equals 224. Divide both sides by 8, and x equals 28. Continuing on to example D. Again, it's 4-sided shape. 4 minus 2 times 180, we get 360 degrees for our total. Now, 17x was the only x listed, and then we combine 8, 66, 110, and 74 for 258. So solving this two-step equation, subtract 258 from both sides, and then divide by 17, x equals 6. All right, so that concludes the notes for section 2.